The 2 by 2 identity matrix is I, which is 1, 0, 0, 1. It's got the property that I multiplied by a matrix A is equal to A multiplied by the matrix I, which is just equal to A itself, provided, of course, that you can actually do the matrix product. Let's just give an example of that happening. So let's just have the matrix 1, 2, 3, 4. Now, top times left will give me 1 add 0. Top times right will give me 2 add 0. Bottom times left will give me 0 add 3. And bottom times right will give me 0 add 4. So we can see that works. Now we've got a couple of expressions here. So we've got a plus 2i squared. So remember that that means a plus 2i, a plus 2i. And we're going to expand this in a normal sort of way. So we'll get a squared. Then doing this, we'll get 2ai. With this one, we'll get 2ia. And I'm writing it that way deliberately because generally with matrices, it matters whether we multiply them on the left or the right. And then finally, we'll get 4i squared. But in this particular case, of course, ai and ia are both just equal to a. So that's going to just give me 4a. And I squared is just I itself. Now we can't just write 4 there. They all have to be matrices, and if we're adding them, they have to be matrices of the same order. Okay, now let's think about a minus b squared. That's a minus b, a minus b. So when I expand, I get a squared minus ab, and it's really important the a is on the left, minus ba plus b squared. And that's as far as we can go. Remember that in matrices, AB and BA are not guaranteed to be the same, so we cannot combine those terms. They have to be separate terms.